All right, so for 1 through 5, we need to factor. What's the first thing we should do for number 1 to factor it?
Take out the variable.
So what are we going to take out?
A p.
A p, perfect. So we always have to take out whatever we can to start. So then what are we left with inside of our parentheses? After we take out the p.
P to the 4th is minus 14p squared plus 40.
Awesome. P to the 4th minus 14p squared plus 40. What should we do next?
Use to the 4, negative 4 plus negative 10.
Awesome. Our two factors of 40 that add to negative 14 are negative 4 and negative 10. So we're going to put those into our parentheses. What goes into our parentheses?
X minus 4 and x minus 10.
Does anyone see what I'm missing? Or, yeah, it should be p. But what am I missing?
You're missing a p squared.
Perfect. So we started with p to the 4th power, so we have to make sure both of these are p squared. Can we factor this anymore?
You can factor the p squared minus 4 and add the p squared minus 10.
Perfect. We can factor the p squared minus 4 because it's the difference of two perfect squares. So what would this p squared minus 4 factor into? What are our two factors?
2.
Perfect. Our two factors of negative 4 that add to 0 are 2 and negative 2. So we have p minus 2 and p plus 2. Good job, guys. So this is as much as we can factor it. So that's our answer. Any questions on number 1? All right, let's go to number 2. All right, how do we factor this?
Divided by 4.
Sure, we can take out a 4. So then we have x squared minus, what's 36 divided by 4? 9. Can we factor this anymore?
Yes.
Yes. Because x squared is a perfect square and 9 is a perfect square. So what does it factor into?
X minus 3 and x plus 3.
Awesome. X minus 3 and x plus 3. Perfect. Another way we could have done this one is from the start, we could see that we have two perfect squares because 4x squared would be 2x squared, and then 36 would be 6 squared. So we could also say that this is 2x plus 6 and 2x minus 6. These are actually the same thing. So either way would work here. All right, number 3. What do we do first?
Divided by 30p cubed.
Perfect. We're going to take out a 3p cubed. 3p cubed. So we're dividing everything by 3p cubed. So then what are we left with?
P squared minus 64.
Awesome. P squared minus 64. Can we factor this anymore?
Yes.
Yes. How do we factor it?
X minus 4.
So 64 breaks up into what?
Negative 12 and 12.
Okay, one person at a time. Gianna, what did you say?
Negative 8 and positive 8.
Perfect. Negative 8 and positive 8. Because we only have two terms, p squared minus 64, this is the difference of two perfect squares. So we have to make sure that our two factors of 64 are the same thing, because that way negative 8 and positive 8 add up to give us 0. That's why we have no middle term. So we have p minus 8 and p plus 8. This is our answer. Any questions on this one? All right, number 4. What do we do here? The sum of cubes, we have a formula for that. We have a plus b times a squared minus ab plus b squared. So this is our sum of cubes formula. We just need to find what our a is and what our b is and plug it in. So remember, a cubed is equal to our first term, which is x cubed. So then what's a equal to?
Just x.
Just x. And then b cubed is equal to 27, so what's just b equal to?
3.
3. Perfect, because 3 times 3 times 3 is 27. So b is 3. Now that we have our x, well, we have our a and our b, we just plug it into our formula here. So we have x plus 3 times x squared minus 3 times x plus 3 squared, which is 9.
Wait, where'd you get the 3 from?
The 3 came from the 27, because just like how we saw that a cubed is equal to x cubed, if we take the cubed root of both of these, we see that a is equal to x. We do the same thing for the b cubed, so we take the cubed root of both of these, and the cubed root of 27 is 3. So if we didn't see that right off to the bat to start, we can see that if we have the cubed root of 27, what does 27 break down into? What are two factors?
9 and 3.
9 and 3. And then 9 breaks down into 3 and 3. So the cubed root means we circle 3 of them, so we would take out the 3. So the cubed root of 27 is 3. So that's how we got the 3 for B. All right, how do we factor this?
Can you do like the grouping method?
Yes. Anytime we have 4 terms, we can try grouping. If grouping doesn't work, then we know we have to do our P over Q, which is what we did yesterday. So let's see if factoring by grouping works. What can we take out of the first group?
X squared.
X squared. And then what are we left with in the first group?
X minus 8.
X minus 8. And then what can we take out in the second group?
-4.
Negative 4. Perfect. Because then that will leave us with an X minus 8. So we have the same thing on the insides, which is what our goal is. So now what do we do?
Then it'd be x squared minus 4 in parentheses and then x minus 8.
Awesome. And then we always need to check, can we factor this anymore?
The x minus 4 can factor into x minus 2 and x plus 2.
Perfect. So we see x squared minus 4 is the difference of two squares. So it factors into x minus 2 and x plus 2. And then we have x minus 8. So this is our answer. Any questions on number 5? Any questions about factoring? No questions? All right. For 6 and 7, we need to solve. So we're just taking it one step further than factoring and setting each of our pieces equal to 0. So what do we need to do first here?
Add 2x squared to both sides.
Perfect. We got to move that 2x squared over. So we're going to add it on both sides. So we have 2x to the 4th power minus 4x cubed plus 2x squared. And that's equal to 0. What do we do next?
Divide it all by 2x squared.
Awesome. We're going to take out a 2x squared. So then what are we left with?
X squared minus 2x plus 1.
X squared minus 2x plus 1. Perfect. We took out a 2x squared, but it doesn't go away. We still need that 1 there. Good job. Can we factor this now?
Yeah.
Yeah. Do we have two factors of 1 that adds to negative 2?
-1 and -1.
Awesome. Negative 1 and negative 1. So we have x minus 1 and x minus 1 is equal to 0. What do we do next?
Take it out equal to 0.
Make each little piece equal to 0. So we have 2x squared is equal to 0, x minus 1 is equal to 0, and x minus 1 is equal to 0. For the first one, how do we solve this?
Divide by 2 on both sides.
Divide by 2. What's 0 divided by 2?
0.
0. And then we would just take the square root of both sides. So what's the square root of 0? 0. And then the next equation, what do we do? add 1 to both sides. So x is equal to 1. And then we do the same thing for the last one. So x is equal to 1. So our answers here are x is equal to 0 and 1. This question doesn't ask for it, but at 0, what would our multiplicity be? Anybody want to take a guess? What would our multiplicity be at 0?
Would it be odd?
It may look like it's odd because we just have 1 0 here. However, we had x squared is equal to 0. So since that x was squared, we actually have 2 zeros, so it's even. So we have a multiplicity of 2. Because technically this x squared means that we have 2 zeros. And then what about at 1? What's our multiplicity here?
Even because it's 2 ones.
Even, but we would have a multiplicity of 2. So on the quiz, if it asks you to describe the multiplicity, you would say, like, we have a multiplicity of 1, we would have a multiplicity of 2 or 3, or however many we have of that number. So because we have 2, x is equal to 1, we have a multiplicity of 2. All right, number 7. Any questions on that one? All right, let's look at number 7. What do we need to do first?
Move the 30 to the left.
Perfect. Subtract 30 on both sides. So now we have y cubed minus 5y squared plus 6y is minus 30 is equal to 0. Now what do we need to do to solve? Grouping. So group the first two, group the second two. What can we take out of the first two?
Y squared.
Awesome. Y squared. What are we left with?
Y minus 5.
Y minus 5. What do we take out of the second two? 6. And then we're left with y minus 5. So our two inside the parentheses are the same. So we're good to go. Now we can do what? What do we do next?
Put the y squared and the 6 in the same.
Perfect. So we have y squared plus 6 and then y minus 5. What should we do next? Can we factor this anymore?
No.
No, so we can just go ahead and set each piece equal to 0. So we have y squared plus 6 is equal to 0, y minus 5 is equal to 0. So if we were just factoring, we would leave our answer as this, but for this one, it's asking us to solve, so we need to find our answers for y. So the first one, how would we solve this?
You subtract 6.
Subtract 6, so y squared is equal to negative 6. What do we do next?
You square root both.
Square root both sides. So we get y is equal to what?
Plus or minus I squared 6.
Awesome. Plus or minus I square root 6. So because we had that negative under the square root, we took it out as an I. Good job, Franco. All right, what do we do for the second one? This just must be too easy for you guys, and that's why you don't want to participate on the easy ones. So we just add 5 on both sides, so we get y is equal to 5. So our answers are y is equal to 5, I square root 6, and negative I square root 6. Any questions on this one? No questions? All right, I think that's the last one on this page, so let's go to the last page. So for number 6, we had 0 that repeated because it was x squared. So since this was an even exponent, 0 repeats. So we have a multiplicity of 2 at 0. And then we have x is equal to 1 and x is equal to 1. So we have 2 1s as our answer. So we have a multiplicity of 2 there. So multiplicity is just if it repeats or not. So it's just how many times we have that number as our solution. So that's why I did the multiplicity in number 6, because I knew that the one on the second page that actually asked for multiplicity didn't have any multiplicity, so I just wanted to show you guys this is what a problem would look like that actually has multiplicity. So if a number repeats itself. Number 8, determine if the binomial is a factor. How do we do that? What should we do for number 8?
Synthetic division?
Synthetic division. Perfect. So what's going to go on the outside?
+4.
+4. So since we have that binomial x minus 4, we change the sign. So a +4 goes on the outside. And then we put all of our coefficients on the inside. So we have 2, 5, -37, and -60. Just have to double check, make sure we're not missing any terms. But we have cubed, squared, x, and our constant, so we're good. We can go ahead and divide synthetically. So we drop down the 2, multiply, okay, so 2 multiply gives us 8. 5 plus 8 would be 13. 13 times 4 is 52. 52 minus 37 is 15. 15 times 4 is 60. And 60 minus 60 is 0. So is x minus 4 a factor?
Yes.
Yes. So yes, it's a factor. So if you get 0 as the remainder, that means the binomial that you tested is a factor. Any questions on number 8? All right, let's look at number 9. Find all the zeros and state the multiplicity. What do we do? So we have 4 terms. What's the first thing we should always check when factoring with 4 terms? Factor by grouping. So we're going to group the first 2, and we group the second 2. What can we take out of the first 2?
negative x squared.
Negative x squared. So what are we left with? What are we
X
left?
minus 1.
If we take out a negative x squared, is it x minus 1?
X plus 1.
X plus 1. Perfect. And then what can we take out of our second group?
A 9.
Awesome. And then what are we left with?
X plus 1.
X plus 1. Perfect. So now we set the outsides in their own parentheses. So we have negative x squared plus 9. And then the insides, x plus 1. We're looking for a 0, so we're trying to solve. So we set this equal to 0. What do we do next? How would we simplify? Can we just set each piece equal to 0? So we have negative x squared plus 9 is equal to 0. And x plus 1 is equal to 0. Because our goal is to solve. Once we have it factored, we can just go ahead and solve. So for the first one, how would we solve this? We have negative x squared plus 9 is equal to 0. What should we do?
Minus 9 on both sides.
We can do that, but does anybody else have another suggestion of what we could do?
Can't you break it down to 3 negatively?
We can, but we don't really need to because we're going to end up getting the same answer if we just skip that step. So since it doesn't ask us for all of our factors here, we can just go ahead and set it equal to 0 without breaking it down and factoring it more. But you'll see we'll get the same answer. All right, let's subtract 9 on both sides, like Gianna said. So we have negative x squared is equal to negative 9. What do we do next?
Square root.
Before we square root, we want to get rid of that negative. So what can we do?
You just divide the negative.
Yep.
Just turn the negative to a positive.
Right. So we want to change the signs. So divide both sides by a negative. So we have x squared is equal to 9. Now we can take the square root. So if we wanted to, we could have skipped a step and in the beginning just added x squared to both sides and moved the x squared to the other side. And it would have saved us from having negatives, but we can subtract 9 also, so it doesn't hurt us doing that. So now we have x squared is equal to 9. What do we do next? X squared is equal to 9. How do we solve this?
It will be 3.
So we take the square root of both sides. What do we get when we have the square root of 9? What are we forgetting? It's not just 3. What's the one thing we can't forget when we square root both sides?
Plus or minus?
Plus or minus. So we have plus or minus the square root of 9, which we know the square root of 9 is 3. So x is equal to plus or minus 3. So anytime you take the square root of both sides, cannot forget that plus or minus. All right, now we have to move on to the other little equation. What do we do here?
Subtract 1 from both sides.
Perfect, subtract 1 on both sides. So x is equal to negative 1. So our answers here are x is equal to negative 1, negative 3, and 3. Do we have any multiplicity here? Is anything repeating?
The 3.
No, the 3 is not repeating because one of them is positive and one of them is negative. So they're technically two different numbers. So we have no multiplicity here. So even though it's a plus or minus 3, that's a positive 3 and a negative 3, two different numbers. So we have no multiplicity. Any questions on this one?
How do you find the multiplicity?
Multiplicity is just if it repeats or not. So if we had, like, the example I did on the last slide, it was, any other questions? All right, we got 2 more problems to do. So let's look at number 10. So we have to write the polynomial with the given zeros. So what should we do here? So this is what we learned yesterday. All right, so our goal here is to work backwards. So it gives us the answers and we need to come up with the polynomial. So we need to put this into factored form. So we have x minus negative 4 times x minus 2 times x minus 6. So it's always x minus whatever number we have. We see that x minus a negative 4 becomes x plus 4. And then that's x minus 2, x minus 6. What do we need to do next? FOIL. So we just take two things, FOIL them out, and then we'll multiply the last one together. So we have x times x, which is x squared, x times negative 2, negative 2x, 4 times x is plus 4, x, and then 4 times negative 2 is negative 8. We can simplify this, so we have x squared plus 2x minus 8, and then we need to multiply this times x minus 6. So we just have to make sure that all three things get multiplied to each other. Doesn't matter what order we multiply them in because we'll end up getting the same thing. So now every term in our first parentheses has to get multiplied to every term in our second. So we have x squared times x, which is x cubed, x squared times negative 6, negative 6x squared, 2x times x is 3x, no, that is 2x squared. So 2x times x is 2x squared, 2x times negative 6 is negative 12x, negative 8 times x is negative 8x, and negative 8 times negative 6 would be positive 48. All right, what's our last step here? What do we do next? Combine like terms. Simplify. So we have x cubed. We have a negative 6x squared and a plus 2x squared, so that becomes negative 4x squared. We have a negative 12x minus 8x, so that's negative 20x plus 48. So this is our answer. Any questions?
How many questions are going to be in the quiz?
10. And it'll be 5 multiple choice, 5 free response. Yesterday, remember we did this problem and it had our conjugates in it. So if we had like 1 plus square root of 2, we know that 1 minus square root of 2 is also one of our zeros. And then we had to FOIL that, which was a lot more work. on the quiz, you're not going to have one with square roots. So it'll be something that looks like this. You're welcome. All right, number 11. Find the given zeros. What do we do?
Don't you like put like numbers on top? There's like a fraction.
Yep,
I don't
so
really remember.
we can't factor this because we have that x cubed and it's 3 terms. So we have to do factors of our lasts over the factors of our first. So what are 2 factors of 48?
1 and 48.
1 and 48. What else?
2 and 24.
2 and 24. What else?
6 and 8.
6 and 8. And I think there's one more.
4 and 12.
4 and 12. There's actually one more.
Isn't like 3 and... I know it's 3 times something.
3 times 16. And I'm pretty sure that's all of them. Yeah. All right. And then what are factors of 1?
Just 1.
Just 1. So all of these are going to be whole numbers. Thank goodness. So to test them, we do synthetic division. What's going to go inside of our box?
1, 0, negative 28, and negative 48.
Awesome. So all of our coefficients go inside the box, and we can't forget that we have a 0x squared here. So just like we did in the last chapter, got to include every single term. So we have to include that 0 there. So we have 1, 0, negative 28, negative 48. All right, what can we test first?
One.
Sure, let's test 1. 1 times 1 is 1. 1 times 1 is 1. This would be negative 27. And 1 times negative 27, 1 doesn't work. So what can we try next?
6.
6. So 6 times 1 is 6. 6 plus 0, 6. 6 times 6, 36. What's 36 minus 28?
8.
8. And 8 times 6?
48.
48 minus 48? 0. Yay, so 6 works. So one of our answers is 6. Good choice, Franco. All right, what do we do next?
Then you do x squared plus 6x plus 8 and you equal to 0. You factor it, I think.
Perfect. We gotta still find the zeros, but now we have a little bit smaller of a polynomial here, so we can see if this will factor. Do we have 2 factors of 8 that add to 6?
4 and 2.
4 and 2. So we have x plus 4 and x plus 2. Our goal is to find the zeros, so we got to do one more step. So what's the last thing we need to do?
Set them equal to 0.
Awesome. X plus 4 is equal to 0. X plus 2 is equal to 0. And we just solve both of these, so x is equal to negative 4, and x is equal to negative 2. So up here, we get 6, negative 4, and negative 2. And these are our answers. At the start, we could have tested negative 4, we could have tested negative 2, and they would have both also worked. We would have gotten a different coefficients down here, but we would end up with the same 3 factors. So if we would have said to try -2, that would have worked. And then we could have just done the same exact thing from there. So this is our answer. Any questions about the review? Any questions about the quiz? Any questions?
I have a question, Carter.
Yes.
How did you get the equation on the bottom?
The one that's highlighted?
Yeah.
So from the coefficients here, that's how I got it. So we just divided out the 6. So we divided out one of our factors, and then we just had this smaller polynomial to work with. So we knew that we started with x cubed. So once we divide, our answer is going to start with x squared. So then this would be 1x squared plus 6x plus 8. Make sense?
Yeah, thank you.
You're welcome.